everybody, and welcome to our next installment of the Repairs Realm. I think we all know everybody at the table, so I don't think we have to go through and do introductions, but we're here today to talk a little bit about electronically controlled suspensions. And you know, Dirk, for a guy like me that's spent a lot of years in racing, I'm used to having to pull my shocks apart and change the valving and look at different fluids and things to try and change the way my shock reacts. Yeah, we had some that were adjustable and things like that, but that's what you had to do.
Yeah.
Now we have these modern vehicles with these electronically controlled suspensions. Crazy. What are some of the options we have out there today?
You know, what you just described is you made your setting for the track where you were driving on.
Right.
So, that's motorsports, that's how we want to do it. And I remember actually in the 90s, the Formula One were like starting to develop electrical shock absorbers. And the problem was the G-force in this curve was so high that there was on the edge that the driver passed out. Then that's what you can do with electrical controlled systems. You control and shock absorber in this moment as you need it. And that's what we want now in a regular car. Of course, we don't want that the driver pass out when he drives too fast. But what we want is we want to give him as much as comfort and as much as safety as possible when he drives in a corner or comes in a dangerous situation to stabilize the vehicle. And you ask what situation or what systems are available currently, and actually most likely two systems what I see mostly. That's just like one is valve controlled. So what we're doing is we controlling the valve, open and close the valve to make the shock absorber harder or make it softer. We want to drive comfortable down the road. We want to have it as soft as possible, as comfortable as possible. We make a quick move, then a kid runs on the street with a ball, and you want to make it this move. We want to control the chassis and have it as stiff as possible that the vehicle is not starting to bouncing. So electrical valve controlled. Or we can control the fluid, and you said it already, you were experimenting with the fluid.
Yep.
So, Jeff, how the hell we can control the viscosity of a fluid to make the viscosity higher or lower to control the ride of a vehicle? That's really crazy stuff.
Before I hit that, I'll kind of echo some of Bud's thoughts, and I was never into racing per se, but I had my share of vehicles in the past that I would work with the suspension on, and if we wanted to get that roll control, that body control, we put a bigger sway bar on. That was the way. You just put a bigger sway bar on. But that wasn't necessarily the magic answer if you still wanted some ride comfort, because that tends to translate that impact and shock from one side of the vehicle to the other. And so with the technologies that have been around for a while now, and most folks have heard the term Magna Ride, they have a very special fluid that is in there, and basically I have a small amount of that fluid in this container, and it has a very low viscosity. It's very thin, and now that I've coated the inside of that, you really can't tell. But it's thicker than water, but I'll say right now it's about 10 weight oil or something. Is essentially the viscosity. I have some of the same fluid in this Petri dish with a magnet on the bottom. That with the magnet on the bottom, it gets that fluid to basically increase its viscosity, draw up to where it is essentially thicker. And the beauty of this is that while I've got a permanent magnet on the bottom of my Petri dish, they can electronically control this very, very quickly. And if I didn't have the magnet on there, this stuff would be pouring out on the paper sitting on the table underneath my hand right now. So this is pretty neat, the technology that they've got in there. And essentially, the concept behind this is what I have on the table in front of me. If they can I'm going to try to figure out where it's going to be. There we go, right about there, where I have basically just two syringes. And imagine that one of the syringes represents the upper chamber in your shock, or the lower chamber, and the other syringe represents the upper chamber. And where you're taking and you're exercising that shock absorber, that fluid's going through a fixed orifice. Well, if that fixed orifice, or that area where that fluid has to travel, has an electromagnet around it, and this is just a coil of wire here, and much larger than what's in the actual shocks. But the concept is the same, that as we're driving down the road and that shock absorber operates, we could very quickly electrically charge the coil And what's neat about it is they can take and, again, extremely quickly alter the amount of electrical field, that electromagnetic field around those orifices, in order to very precisely control the viscosity of that fluid, and hence the dampening properties of that shock absorber.
And we talk about milliseconds. So
right. No, it's interesting, right? Because we're used to, when you get into these performance vehicles on the streets, you're used to a pretty stiff ride, you know, pretty rough. And I know my son has recently purchased a vehicle that has Magna Ride. And I got in the car for the first time, and we took a good road trip, and I thought, boy, this is going to be rough. We're going to be bouncing. It goes down the road really smooth. It doesn't get stiff until, as you said, when you start to turn and you need that performance, then in a blink, it's changed the system entirely. It's really pretty amazing stuff.
Yeah. And so the tie-in, you know, I know, having been in a similar vehicle to his, where you know, he can essentially select the ride quality.
Yep.
You know, right there, sitting in the driveway, or dynamically, you know, as you know, depending on how spirited he feels.
Hey, can we go back to your experiment? I would like that you show the folks a little bit. You know, that thing is so impressive when you have this magnet. Take that magnet off. So you know, you hold that down, and usually it would drip out. Take that magnet out, that you see how the fluid will distribute.
You want me to get messy, because I don't have my gloves on. So I'm going to try to do this without. And
whoa.
Uh-oh.
Uh-oh.
You
really made him. I didn't tell. I didn't say.
Hey,
Jeff,
you told me to take the magnet off. You know there's a risk involved here.
Oh my goodness.
Okay. So we'll have clean up aisle 4 afterwards.
Great. All right.
Okay.
So, Scott, I believe RTS has an article that you've published that really addresses all of these electronic controlled suspension.
Yeah, you know, I think we don't have a lot on the website. We have an article that just kind of goes into it, and this active suspension, so we talked about the ride quality and things like that, but it's also tied into fuel economy. So they're actually controlling some of these systems where, you know, it rides lower or higher according to, you know, the improved aerodynamics. So a lot of consumers are not even going to realize that their car's equipped with this kind of stuff. Some of them have the push buttons and things like that, but others, it's just automatically happening, and it really, you know, it's one of those things that you have to be aware of it when we're doing these repairs, and have to have a basic understanding of it, because you have to know when it's working and when it's not. And if, you know, you got something that got hit in a wheel, you better know what's on there and what is expected when you're working on it. So the article that we have on the website really just goes over the, you know, kind of some of the basics around it for aerodynamics and how it adjusts and changes according to what it needs.
So it's, you know, if we try to relate this then now to the collision world, as we're replacing, you know, we're used to replacing shocks and struts where you just bolt these things in and make sure everything's good and tight. It's where it's supposed to be, send it down the road. Where these systems now, there may be some calibrations that have to be performed to make sure that these systems are set up properly and functioning properly.
Yeah.
It's really interesting stuff. All right, so while we were talking about there, Jeff and Dirk made it over to the vehicle where they're going to do a little demo for us. So if we can switch over to Jeff and Dirk, we'll let you guys take it from there.
Yeah, thank you, Bud. So I'm here with Jeff at the vehicle. So that vehicle has a magnetic ride strut shock absorber. And Jeff is holding a little handheld to give you guys a better view of everything. And maybe, Jeff, you can guide us through what we're seeing here.
So this vehicle has Magna Ride struts on each, or shocks and struts on each corner of the vehicle. So that gives them ultimate control over all 4 corners. It also has ride height sensors, and I'm going to duck back down in here with the camera. And there you go, right there. Yeah, you can see the lever arm coming off the sensor, and then the connecting arm that goes down to the control arm right there. So that ties in with the vehicle dynamic management system.
And they're also on all 4 corners.
All 4 corners. And that allows them to, and they also tie in with some of the other onboard systems. They'll pull some data from restraint computer for lateral acceleration and other information there in order to really understand what's happening with that vehicle as it travels down the road. And As we look at service to a system like that, it's relatively straightforward when we're doing suspension work or replacing struts and things like that, so far as the mechanical aspects of it go. But ultimately, whenever we're done with our service work, whatever that happens to be, then we're looking at certain calibration procedures. And it varies from vehicle to vehicle, but we've looked at some of the information here. And what I find really intriguing about this, and I'm going to ask him to go back to the camera that I'm holding in my hand really quick here. We pulled back the wiring harness and the covers. You know, it's basically a two-wire system. We know that there's two electromagnets, if you will, inside of this shock. And essentially all they're doing is they're using pulse width modulation to take and modulate the current that's applied to change the viscosity to that fluid to whatever that driver's preference happens to be, or under those cornering situations, as you mentioned, where they can stiffen up one side but let the other side stay a little more relaxed for ride quality.
So when I put a collision scenario, you know, you have to replace maybe the shock absorber, and you see directly the wire goes here in, maybe something is damaged at the wire and you don't catch it on the first glance. So you put your new thing in, you do your calibration, what we talk later about it. How would be the vehicle or the system behave when that would not get in current, and it's not in operation? Yeah, when there would be.
So if we had an open in the wiring, and I would hope that folks are doing their scanning along the way and diagnostic work to flag, because it would flag a code. But ultimately, the default would be in this case, the fluid's going to be in its thinnest viscosity, so it ultimately have the soft ride quality on that corner of the vehicle. And again, hopefully folks do their diagnostics, they pull that diagnostic trouble code.
So here it would be a soft ride at this corner. What that whole behavior of the vehicle, it could be actually really dangerous. When you think you have one corner what is super soft and everything is operating normal. I assume they will go in a safe, default mode to control that. When I look other systems, for example, those systems would have valves.
So with the valve systems, and we don't have an example here, but I'm sure many of you have seen where you'll be working on suspension and you'll see external valves that may be mounted somewhere on the shock or the strut. And so the default on that becomes...
That is opposite, actually. That would be super hard.
Okay.
So they're controlling the valve and make, with current, to open up the...
To soften the ride?
To soften up the ride. So default would be always hard. So that's the difference. So maybe for safety, a little bit better solution, but you know, the system will flag a code. You have to calibrate that, and that is what you guys have to be aware, that you have to do those stuff.
So we're going to step to the front of the vehicle here really quick.
Let's
we
go.
do have the OEM scan tool connected, and we're not too worried about seeing all the details of the screen, but just from a reference stance, of course, you'd be able to look at live data, whatever's available for that vehicle. On this vehicle, you can look at the ride height sensors to see what kind of data they're reporting and things like that, and a lot of other status information. At the same time, as we look at the calibrations, which, initially whenever I looked at this vehicle, it's just like, okay, you're going to calibrate the suspension? Wait a minute, I'm used to doing wheel alignments and things like that. And so it was good to look at the service information and then dive into the scan tool. And so they have a vehicle dynamic suspension temperature calibration routine. And they also have a suspension height sensor calibration, which after you've done any of that suspension type work, ultimately, those are pretty straightforward routines to run, but you do have to take and get the vehicle sitting on a level surface, use the scan tool, run them, and during part of that, as part of the instructions that come along, or take the vehicle for a drive at some point. And there's, again, very strict requirements on the temperature one as they look at getting some sort of a standardization relative to that fluid and its viscosity at a certain temperature. So it's all important stuff that gets done to make sure we have a complete repair.
The shock absorber themselves didn't have to be programmed, but we have to align all 4 ride height sensors and calibrate them and make sure they are right. You know, I know, for example, different systems, and I more grew up in the environment of those external valves. I mean, I use an example as BMW, for example. They use on each strut, they have a control unit, a slave control unit, what communicates with the master inside. And they have also a speed sensor in, so that we...
So they look at the rate.
The rate, the
of
speed,
movement of the suspension.
movement of each corner, and then they control each individual to that. So that's how BMW is handling and with those systems. So a little bit different, but the same scenario. You have also your ride height sensors. So there is a lot of different scenarios and different systems out there, and I think they're coming and coming and coming more and more.
You mentioned that, and I'm not an expert on the really high-end systems, but I have done quite a bit of research, and I've seen where in some cases they look at accelerometers at each corner of the car that can kind of sense the movements going on. And I believe you've got some insights you'll share with us a little bit about some of the other more advanced systems.
Let's give it over back to Bud, and we make our way back to the desk.
Great. So I think that tells us a lot about Dirk's driving style, doesn't it? He right away goes to the safety side of it because he's got one shock or strut that's going to behave differently than the others. But
I think
that tells us a lot about you.
You know, guys, the difference between you and me, I had the pleasure to grow up on the German Autobahn. So, you know, driving there with 240 kilometers per hour for longer distance. So you go on the Autobahn, push your throttle down, change the gears, then we have manual, not automatic. That's only for America.
So I grew up on the Washington Beltway. 2 o'clock in the morning, wasn't too bad.
That's right.
But I think it's another example of, you know, these vehicles are getting more and more complicated. There's more things that they're monitoring because they're worried about fuel economy. They're worried about, you know, the safety and the ride and all those things, all those creature comforts that a lot of people, you know, if you get in a vehicle from the 60s, it's a very different ride than even the low-end car today. And, you know, that's one of the things that I think we have to be aware of as we're working on these vehicles. 5 years ago, what they had in these vehicles is not what they have now. And it's just another example, because we're always talking about the EV and the ADAS and the structure, but some of these other little peripheral systems that we don't really think about a lot of times are also changing drastically.
Yeah, well, and to Jeff's point, hopefully everybody's out there doing their pre and post scan the way they should be to catch these kind of things. Because if we don't, that's when it turns into that customer gets the vehicle and they're driving it for a minute and they say, yeah, something's not right. And they have to come back to the shop, and that never goes well. So hopefully we're looking at that stuff, doing our pre and post scans and catching this stuff the way that we should be.
I think about the importance of all of the technologies, no matter what they are on the vehicle, working the way they, as built, as designed. You know, so whenever that customer has that vehicle under, I'm going to say, adverse conditions where, you know, things aren't going ideal for them out on the road, there's no compromise in anything. So hopefully everything does its job on time and as needed, and either prevents or mitigates the severity of whatever happens.
Right. Because to the point, it's not just about performance, right? It's stability, and it's all those things that are built into these vehicles to make sure that if you have to swerve, as Dirk talked about when he was going to run over the neighbor's dog or whatever it was he was doing earlier. You know, it's keeping that car stable when he's trying to get around that kind of situation. So it's important stuff.
The point is really often you can make this, you can avoid this crash, you can get around this obstacle. But then is the question is, so how fast is the vehicle stabilizing themselves and keeps the control over that the driver can control the vehicle. When the car starts, how you call it,
Swerving, swaying.
Swearing, sorry, that's hard for me to pronounce. Doing this, then you lose the control and then you have the accident. But what you guys, and you were saying to the beginning, you put a stronger sway bar in. So now we're putting electric motors in the sway bar or hydraulic system to control that stiffness of the sway bar. We have electrical shock absorbers what control the damping characteristic of the moment what we need. Then we have, oh God, now we can go endless what is coming into those systems. Electrical steering racks, what helping, and that will be another episode what we want to talk about it, and there's so much cool stuff to talk about it really in there. There is so much more, and then we have this ADAS stuff and a camera and radar, and all of a sudden Mercedes says, hey, we have a camera, so we can monitor if there comes a bump in the street.
So, well, that's interesting, but just real quickly, if anybody has any questions, please type them into the chat, because we're nearing the end of our time here, and we will get those questions as they're entered. So it's interesting you talk, though, about the cameras and seeing bumps and things like that. There's vehicles out there even now that allow you to program into your vehicle, there was a bump here, there's a speed bump, and set it and it remembers. The next time you get back to that area, it raises the vehicle. So that's, I mean, all of these things tie together with this electronically controlled suspension.
So come back to Mercedes. What they're doing is like they call it magic right now, magic body control. Everything is magic, and the reason why they call it that, I'm laughing, but I love that word, magic. So they see, oh, there is a bump. The camera identifies there is a hole, a bump in the road. So, and they identify, okay, we possibly will hit that with the left tires. So they're adjusting the left tires towards this bump. And the goal is to create something what they call a sky hook motion. Sky hook means like you have a hook comes from the sky, holds the body of the vehicle, and the tire is doing the work, but we don't want, or they don't want, that the chassis or the body of the vehicle is moving. That we give the perfect comfort and ride that the US president sits in his Mercedes. Oh no, that's in Germany. The German president drives always Mercedes. What the American president drives, by the way? I have no idea.
I'm not sure.
Oh, you don't know? I'm kidding you guys. This is this is like a prestige thing in my. Okay, whatever. Forget prestige. No, guys, I was kidding. So no, but really coming back to the story is. Ride height and height control, and have that chassis in one height and let the tires work. That's the solution here for the comfort. And I think that there is a lot of cool systems out there, and I know Lexus is doing something what goes in the same direction. So this is not rocket science. This is something not what is new. This is technology what we have in those vehicles already since 20 years.
Yeah,
so
but you're seeing it more and more frequently.
More and more frequently, yeah. Then manufacturers investing more in this.
Yep.
So I was so happy when I see that Mustang axle, and I see all those control arms and there. Then I got a lot of friends in the US send me always a picture. There's like a picture like there come 10 control arms controlling tires and said German engineering, and then you have something simple next to it. Hey, you guys going in the same direction?
We did it with two.
All right.
So
it doesn't look like we have any questions at this point, so we'll go ahead and wrap this up. Our next episode is going to be on electronically controlled steering. So look for us again, same time, noon Central, and we'll see you then. Take care.
Thank you.